pleasure to be with you all this morning and this evening, depending on where you are in the world. As Shilpa mentioned, my name is Bryan Austin. I am the Principal Detection and Response Engineer for Appalachian Security Services. It's a company I founded about 6 months ago. I've been working as a security operations strategist, performing independent contracting and consulting for a number of different organizations, providing services, everything from building custom detections and use cases to helping backfill analyst processes, as well as building automations and integrating AI systems into current security operations environments. So it's great to be with you all today. On a personal note, I'm also a father, a husband, a farmer, and if you can imagine a nerdy or redneck hobby, I probably do it. I'm in one of the rooms in my home, and right next to me, I've got all of the stuff to do freeze drying and my son's in my Warhammer game. So we have a lot of fun with it, but I'm very passionate about security operations and making things better globally for operations teams and making the world a safer place for my children as well as the children that come after them. So kind of gives you a little bit of idea of where I'm at. I'm also a major proponent of focusing in on practical cyber defense. So I want to make sure that we understand that the defense operations that we put into place are the ones that are the most useful. And that is what leads us into this topic today, talking about the fusion of artificial intelligence, threat intelligence, and security operations in building a more effective defensive strategy. So to kick this off, on the average daily enterprise gets roughly 3,000 alerts in a security operations center per day. Large enterprises get in excess of 10,000. So we're looking at a major volume of alerts that come in every single day from the environment that a security team monitors and manages. This can be extremely overwhelming. I've worked in incredibly large teams that were 50, 60 people, and we were coordinating globally. But I've also, one of the teams that I'm currently working with, there's only a couple of us. So these volumes get overwhelming quickly, especially considering that you can see that there was an incredible amount of false positives. I know in one environment that I've worked in, we were dealing with upwards of 80 to 90% false positive rate. And that requires a substantial amount of tuning, but at the same time, you're having to maintain the volume of alert closures to keep the environment secure. As you can see, we've also talked about how AI is starting to transform things. The Mythos and Project Glasswing coming out of Anthropic performed an assessment of vulnerabilities over a course of 90 days on open source GitHub repos. They found a total of 6,202 critical or high vulnerabilities over the course of that. Of those, 1,752 were independently assessed, and over 90% were assessed to be true positive and confirmed. 62% had their criticality confirmed. So I think I had this part a little bit wrong, but 46% of the alerts that we get in a SOC are false positives. I put that on the wrong side. Sorry about that. So you can see that there's a substantial shift happening, and it's going to make life much, much harder for a single person to manage and monitor a queue. On average, I've found that to perform a very effective investigation, it can take between 20 and 45 minutes to effectively cross-reference all data sources manually across multiple points. This is untenable for humans dealing with this volume of alerting, especially as budgets shift, as the geopolitical climate changes the way that economics works. there's less money in security operations to bring in analysts to just sit and monitor. So that brings us into a point of what can we do? We look at why SOCs are failing, and I would beg to differ on the wording there. SOCs are not necessarily failing. SOCs are struggling. They're working hard to perform the work that they're doing. They're doing effective jobs, but they're also being asked to do a lot of things that are outside of the normal scope. So critical pieces here are alert fatigue, which we've just been talking about, but also limited visibility. A security operations team can only see what data is feeding into them. So if they are unaware that a tool or an entire subnet of the virtual LANs exists, they're not going to be able to process what's there. So the visibility is largely dependent upon other teams working in conjunction with the security team to ensure that they are aware. And in high velocity environments, that's a very hard thing to do. The other main issue that I've seen is tool sprawl. Something on the order of, I think 20 large organizations have something on the order, 90% have over 10 tools that the security operations teams are operating out of. We had about 40% were operating with over 20 tools. Previous to this, I was working in an environment where we had 25 tools that my team was responsible for. It's incredibly challenging to make sure that you are bouncing between each of those consoles and giving the appropriate level of attention to the alerts and the data feeding from that. Even if you use it for a cross-reference point, doing it as a manual process is incredibly challenging because you have to hold those documented processes, those workflows in hand to make sure that you're following them every single time. And I don't know about you guys, but as you can see, I stumble over my words. I bounce back and forth. I forget little details. So I make unholy numbers of notes. I have sticky notes stuck all over my laptop. And it still doesn't make me more effective at remembering these details, because we as humans are only going to be able to hold 3 to 5 immediate pieces of information in the front of our mind in short-term memory at any given point. Well, there are some exceptions to that. Some are more, some are less, but it's a challenge to monitor and maintain that level of tool sprawl. But the other issue is reactive approaches. We're dealing with things that are changing so fast. The velocity of iteration that is not only happening in threat actors, but also inside of your environments is happening at a rate that is almost impossible for a SOC manned by people to maintain an operational cadence with. So what do we do? How do we handle this? And ultimately, the focal point that needs to be around marrying the tools that we have in hand, things like artificial intelligence and machine learning, which those have largely been around for years, but they're becoming better. They're iterating faster. They're moving in a better direction. But those two can shift your security operations environment from a reactive stance to a proactive stance using intelligence-driven and artificial intelligence supplemented capabilities. So the current state and the challenges that we're dealing with, we've talked a little bit about this already, and it's the 3 V's: volume, velocity, and variety of alerts. The volume that we get, we've already discussed. The velocity that things are coming in, it's happening constantly and very, very quickly. And the variety, the alerts that we get are constantly changing, but they cover a very broad spectrum. So we need to understand that we don't have to cover the entirety of the MITRE ATT&CK framework. That's where intelligence and artificial intelligence drive in. So the amount of noise becomes incredibly overwhelming very, very quickly. As I mentioned, 69% of organizations use 10 or more tools. 39% use 20 or more. That's an absurd number for a person, especially because There's one tool that I've worked with, and it's a SIM platform. When you log in, if you link it from anywhere, you have to SSO in every single time. So each login takes, it doesn't seem like it's much, but it usually takes between a minute to a minute and a half. But when you're doing that multiple times a day, it starts to tie you up and drag out the analysis and processing process. Additional issues are the fragmented visibility. So cloud services that are constantly being spun up. A lot of dev environments create these. Traditionally, we've called this shadow IT, but it's not really shadow IT. Development environments, things like that, are generally an accepted and approved part of the business. But those cloud services being spun up and spun down can sometimes have integrations with the larger organization, allowing greater threats and greater risk toward that. So those are things that have to be monitored and maintained from an external footprint perspective, as well as from an internal footprint perspective, which adds yet another tool into the tool stack. These are all challenges. Forgotten hosts. There was an organization that I worked in. We had a Windows 2000 server running, and we could never figure out where it was. It took us 6 months, and finally we found it. Someone had plugged it in a stairwell on the bottom floor under the stairs, and we found out that it was actually an accepted and required part of the business. It ran a critical piece of infrastructure, but nobody even knew where this was. Nothing was documented, so we had no idea. And these are challenges that we face. So moving on, the adversarial iteration, we're looking at, based on information from FireEye, there are 1,900 unique clusters of threat actors. This is not just one group doing 1,900 things. This is 1,900 separate signatures. The interesting piece about that is that report came out in 2021. We're now 5 years beyond when this was released, and the adversaries are only growing. So we need to understand that the human bottlenecks that are generated are burnouts, budget restrictions, skill shortages, because it's hard to develop skills, especially with that many tools, and develop a level of proficiency with them. I've been doing IT and security for the last 25 years. I started when I was in high school. I've been doing this a long time. I've seen a lot. I've done a lot. You know, what's the insurance commercial? You know, we know a thing or two because we've seen a thing or two. But I still don't know everything. You know, I hate using the word expert on anything because there's always something more to learn. There's something more to grow into. But these skill shortages are absolutely critical, because if, you know, right now I'm working with 4 different query languages for different SIEMs. We've got Custo, you've got XQL, you've got SQL, you've got Splunk query language. You could do all of these, but you're not going to be really truly effective and proficient with all of them if you continue adding more. And then the slow response times. The human brain can only process information at a specific rate. So we can read and understand exactly what is being said to us within a specific time period at a rate of, I apologize because I don't have this exact statistic in front of me. I believe it's something on the order of, the average human can read and process between 80 and 100 words per minute. We are only able to process data at that rate. When you look at the capabilities of artificial intelligence and machine learning algorithms, they process data at 100,000 words per minute. So it's a pretty substantial difference. And when you're holding up based off of what a human being is capable of, that is going to delay your capabilities. There was a recent report, I believe it was also from FireEye, I might be wrong, but the average dwell time for a threat actor on an environment is less than 90 seconds from initial intrusion to exploitation. My experience has been a little bit different. Usually my experience has been that a threat actor will get access and will be able to do initial access and initial management of an environment, but then they will hold for 24 to 48 hours before initiating some kind of second stage. Generally, that indicates that they're using a second group in order to perform lateral movement, infiltration, and maintaining defensive evasion and securing their beachheads. But it still is a very short turnaround, especially for a human being over something like, say, a holiday weekend. So artificial intelligence is absolutely transforming threat detection, but not only threat detection, threat response. So the machine learning for anomaly detections, things like UEBA, were historically not great. They had a very high rate of false positives. We had a lot of challenges that we were dealing with in terms of how the system operated, what it detected, what it didn't detect. But the patterning is becoming much more effective at tracking this information out. Now, one thing I will say about anomaly detection, using anomaly detection, what it will do is it'll run in your environment monitoring for a period of time, usually a week, 2 weeks, sometimes longer, depending on the size of the environment. But the issue is that it does assume that all activity in the environment at that moment is expected and benign, which leads us to a point of we need to make sure that our iteration of training these models is absolutely on point. We need to be doing this on a regular basis because these are not tools that you can just set and forget. Remember, our environments and the world around us are changing at a continuous rate. So these are pieces that need to be constantly monitored. Pattern recognition is another piece where you can see that artificial intelligence and machine learning are phenomenal capabilities because those pattern recognitions are great, especially across massive data sets. As I said earlier, you can only process data at about 80 to 100 words per minute on average, whereas a system can process it at over 100,000. So the human brain is wired for patterns, but we can also hallucinate patterns that are not there. I think everybody's probably seen the meme of Charlie from It's Always Sunny, with it sitting in the mailroom, freaking out with red yarn everywhere. He's seeing a pattern, but it's not necessarily there. It's just something that he sees. Our brains are wired. It's the same reason that when you go and lay out in your grass and you look up at the sky, you can see a pattern of an animal in the clouds. You look and you watch the cloud drift by and, oh, it's a giraffe. Oh, that one's a horse. It's not, but your brain is processing the image. I wanted to add an image into this to demonstrate that, but I kind of ran out of time. The artificial intelligence and machine learning systems can create those patterns faster across much larger data sets than a human being will ever be capable of. We're talking about gigabytes of data in seconds. So by dumping your information into a data lake, an artificial intelligence system can be used to trigger across that. These are patterning recognition systems that you can set up in things like Azure Logic Apps if you're wanting to try building your own. There are also tools out there that do it for you. Some tools that I've worked with are things like WireSpeed and ContraForce. Historically, both Phantom, which became Splunk SOAR, as well as Demisto, which got merged into Palo Alto's XIM tool, those all have that capability built into them. So there are tools out there, and there's a lot of open source and free tools that you can find. These are phenomenal pieces, but one thing that needs to be pointed out is data needs to be cross-checked, because one thing that we've found in dealing with artificial intelligence is a lot of these tools act like puppies. The reason you can train a dog very effectively with treats and with, birthday voice and things is because a dog wants to please its owner, its master. It wants to follow through, and it wants to do exactly what's going to make you happy, because when you're happy, he's happy. Yay! The artificial intelligence system wants to make its users happy. So it's going to present data, and it may not necessarily present data that is relevant, but it will hallucinate data. So there was a story that a friend of mine told me that a company he was working at, they had replaced most of their finance department with an artificial intelligence system. And it had been performing data analysis for about 3 months. They used that to build their 5-year plan. And then when he went and cross-checked the data, they found that it had hallucinated all of the sales figures. Every piece of information that it had based its predictions off of, none of it was accurate to what was in reality. But there was no one cross-checking it and ensuring that the data is there. So this is something that you've got to be very vigilant about, is making sure that the data that you're getting is the data that is actually usable. Of course, this all leads into the capabilities of predictive analytics. Predictive analytics is typically based off of things like historical data trend analysis and capability mapping. So in threat assessment, what you're looking at is, what do threat actors typically do? How are they actually operating in the environments, and what kind of trends do we see from year to year to year? Do they have a specific preference? One of the things that I like to do with the organizations I work with is I initially create what I classify as a company profile and a threat model. I take an open source assessment of an organization, and then I look at, based on things like industry vertical, geolocation, the types of data they handle, their revenue, the number of employees, all of that can factor in. But I like to look at tools like Verus, and I'd like to see, okay, what other organizations of similar size, similar locations, similar industry vertical, what kind of challenges are they facing, and how does that factor in to what threat actors are targeting these organizations? And then you can take a look at, what do these threat actors historically do in targeting organizations. That gives us that predictive analytic. That also gives us a focal point on what to develop our defensive operations around. Some key enhancements that we can go ahead and take a look at. Reducing false positives to manageable levels. So a personal anecdote. An organization that I've worked with was dealing with over 2,000 individual alerts over the course of a week. With grouping, that dropped to 1,500, which was great, but that's still a lot for just a couple of humans. The AI tool that we used in this instance was WireSpeed, and based on independent correlation, it was able to assess, based off of how these alerts had been closed historically, what data was available to it, its own pattern recognition, and the intelligence data that we fed into it, and that it generated itself. Its decision agent was able to determine the number of false positives, and it reduced it from 1,500 grouped alerts to 20. 20 is way more manageable. And that dropped a level of effort that the analyst was having to perform, allowing them to take a step back and begin to build new and better use cases, as well as tuning old use cases. The system can correlate signals from multiple sources. So, again, using WireSpeed just as it's the front of mind right now, WireSpeed can correlate information in this environment from Azure, it can look at their Intra ID, it can look at their Office 365, their security tooling, all of the logs feeding to their SIEM, as well as a number of different intelligence sources. So if a user logs in from an unusual IP address, it can cross-reference that data quicker than I can to find out, oh, this is actually just somebody logging in via ExpressVPN, and this is permitted activity under the company policy. Ta-da! And it was wonderful. It makes life much easier and much better. So these data streams that may be in the SIEM, but are not directly referenced in the use case, they're another point of that challenge with a human being tracking that out. So AI can create an automation and an alert enrichment for contextual analysis, as well as historical analysis and review. So this is going to streamline and build out capabilities. These things make our lives as defenders a much more palatable piece. Ultimately, detection alone is not enough, but intelligence is what makes that detection actionable. What I mean by actionable is it's something that you can have an active response and capability to prevent or to reduce the level of risk or harm that a threat actor is able to perform. Ultimately, the roles of threat intelligence in proactive defense are helping to evolve threat intelligence. So threat intelligence at its core, the entirety of the security operations landscape starts out with alerting, moves over to detection, response, and analysis, moves to incident response, moves to the threat intelligence, moves to penetration testing and red teaming to verify, moves back to alerting. So each piece feeds all of it in a continuous cycle. An alert, it feeds the incident response based on what it finds. Incident response feeds threat intelligence with the data points that it finds reference to the threat actor as well as the organization as a whole, but also it feeds the capabilities of these targets. That feeds in to your red teams and the teams that are doing threat actor emulation. That allows them to verify the pieces that threat intelligence feeds to threat detection and response, building out new use cases. You can test those with the red team. Once you've verified that, those can go live back into the analysis process, and that cycle continues to feed, and it creates that wonderful feedback loop. Intelligence-driven SOCs are driven by what actually are the threats that they need to face. If your organization never touches a credit card, you really shouldn't worry about the targeting of use cases that are going to focus on credit card skimming from groups like Fin7. Focus on the active activities that are being targeted at organizations like yours. That's where the company profiles and threat models come into play. Understanding what type of targeting you're facing, but also understanding the types of organizations and the types of activity that is going to be directly affecting you are critical. So again, even if it's a threat actor that might actually be targeting you, if they're targeting checkpoint firewalls and all you've got is Palo Altos, there's really no point in trying to focus in unless you can take a correlation of that. And you can say, oh, well, these would actually translate over. That's a good point to have your red team and your intelligence teams working very closely together. Additionally, real-time threat intelligence integration is absolutely critical. As soon as data comes in, it needs to be fed through. We just saw the release of several critical CVEs going and targeting the Palo Alto Global Protect systems. That is something that needs to be handled immediately because, as it was reported, CISA was letting everyone know, and that, for those that don't know, that is the United States Department of Homeland Security Critical Infrastructure Security Administration. they immediately released a notice within the last few days that this was actively being exploited by threat actors. So having that real-time integration and understanding what are reliable data feeds and having those feed that information into your models will help you to more readily iterate on what the threats actively are. Additionally, moving from descriptive analysis to predictive analysis is absolutely critical. So the way that I teach analysis is descriptive analysis tells you who, what, when, where, and how of a threat incident. Explanative analysis explains the why. It tells you what the motivations are, what the targeting and the actions on objectives are. But it's the why that helps you to build that capability out and understand. And then predictive analysis tells you what's next. What is this threat actor most likely to do? And you can do that on a small scale, looking at their attack chain. If I detect and I've got a reasonable belief that this threat actor is a specific group, I can then effectively predict what the next movements of this organization and this actor are going to be. And I can, to quote the old American Westerns, head them off at the pass. That's a critical piece to moving fast as a threat organization. Now, looking at how can AI supercharge these threat intelligence feeds and this data. Threat intelligence has a wonderful capability like large natural language processing of intelligence sources. There was a woman at a previous organization, her name is Yaman Khalifa. Yaman and I were brainstorming one day, and she's easily one of the most brilliant people I've ever met. In the course of a 20-minute conversation, I was talking about what I would love to see. I would love to have an AI model that would just go out to something like Malpedia, and it would read the articles and it would process that. It would send me an update, and it would pull out all of the independent indicators, and it would go ahead and dump those into a data feed like MISP, and we would just be able to feed that in and use that for retroactive threat hunting. And I went on for probably 20 minutes, and she just was silent. And at the end of it, she said, "So you mean something like this?" As I was talking, she had built a model. And it's incredible to see that level of capability. But that model made everything much more effective and much faster in our organization. We were able to iterate on threats before they became mainstream. So, not to sound too much like a hipster, but we were knocking bad guys out of the sky before it was cool. And it was wonderful. The automation of mapping indicators of compromise, but not only that, indicators of attack to the MITRE ATT&CK framework helped us to keep track of what types of threats do we have based on these threat actors and these activities that we expect to see, and where are we still seeing some gaps. But this gave us that level of capability. The risk scoring and prioritization we perform based off of the threat model of the company. So again, if I'm looking at really hot information on Fin7 on how they're doing new card skimming, that's wonderful. But if the company I'm working with doesn't do any card processing, it's no longer useful for me. So I need to be able to discard information, maybe keep it into a data lake just in case something does come up later. But you want to have the ability to prioritize, because that's now a low priority versus somebody who is actively exploiting a new, like we said earlier, the VPN authorization bypass for a remote code execution using Global Protect. We want to be able to focus on what matters, because if we get hung up on details and we start working our way through useless information or information that is lower value than more critical points, and we don't have that prioritization, we are going to struggle to keep up. The proactive outcomes need to be focused in, and we need to be driving toward metrics. This is something that from a practitioner standpoint doesn't mean a whole lot to us, but this is how we get funding. This is how we get support. We need to be able to communicate effectively what we need and what we're doing to executives. So, pretty colors and lots of pie charts. But understanding that what organizations are looking at from a business standpoint is not revolved around the threat. It's not revolved around the actual work. It's revolved around risk reduction and understanding what risks are presented to the organization. Are we mitigating those risks? Are we accepting those risks? How are we offsetting a potential cost to the business? And the more we can couch it in that language, the more effective we are going to be at communicating threat intelligence, artificial intelligence, and cybersecurity. So focus hard on getting that. And I wholly encourage anybody to go and continue to expand their education into understanding not just your field of study, but understand the people that you're going to be communicating to. So by building out these outcomes, we can perform threat hunting in a more automated way. Threat hunting is basically just taking a look at an incident response and working it in reverse. So I'm not waiting for an incident response to come to me. I'm going to assume that there is already an actor in my environment, and I am going to go looking specifically for them. We're not waiting for the crime. We're going to find the evidence before the crime even occurs. And if there's something that's there, then we're going to catch it. But if there's not, we're going to be able to put defenses up to figure it out. As I mentioned, I play Warhammer 40K. My favorite group is absolutely the Custodian Guard. And they have this thing that they do in the lore called the Blood Games. And what this is a custodian attempts to break into the most secure facility in all of the Imperium of Man. And they try to find new weaknesses, new vulnerabilities. And it is the job of every other Custodian Guard to stop them. So the US military does similar things. They call it red teaming. Guess where we got the word for pen testing and targeting and active threat actor emulation on our side. These are all pieces that feed into that. And being able to perform that faster and in a more automated way is going to help us to build those preemptive controls and to simulate those attacks. This gives us that level of visibility that we never had before, but it also gives us the ability to iterate and move faster than we have ever moved before. The modern SOC architecture is built around the SIM and XDR platforms. A lot of these have got AI models built into them, but the key piece of this is that we need to understand how to leverage what they have. Sometimes the documentation is great. Sometimes it's absolutely garbage. It's a mixed bag, but don't be afraid to find a safe corner inside of those tools to tear into it and really try to figure out how to use that AI that you have access to augment your platforms. Take a look at your infrastructure, see what you've got as a capability. You may not have the ability to pull something specifically in terms of a new tool you have to pay for. There may be a place where you can host an Olama server and you can use that to do that targeting. But you also need to look at practical integration points. So alert ingestion, triage, enrichment, prioritization, all of these pieces you can use as a proving ground for artificial intelligence. To perform the initial triage, you can have an artificial intelligence agent go in with the ingestion of new alerts, and it can perform that contextualization and that enrichment based on intelligence sources. If you don't have a threat intelligence management platform, something like MISP or Intel OWL or something like that, you can use it to feed from open source feeds. They're less reliable, but it's something. And something, perfect is the enemy of good. And being able to show incremental improvement can get people on board with helping to invest. People want to back the winning horse. So by driving forward on that, you're going to get there. Additionally, integrations with the players playbook automation to perform automated response is absolutely going to make your life easier. But you need to make sure that these are either low risk or high fidelity cases in which you have those response capabilities. Otherwise, you are going to run into issues where the data is not being properly fed, and you're going to have problems with that. Additionally, looking at real-time dashboards with risk heat maps and predictive timelines, things like that, if you can build those into your platform, they're phenomenal for telling a story. Because ultimately, our job as security practitioners when we are communicating with executives is to tell a story about how this affects the risk of the organization. These pieces help you. And ultimately, you can use these pieces to create a visibility improvement of a single pane of glass. An artificial intelligence system with multiple API ties can feed data from multiple sources, and it will allow you to be more effective in tracking out what the actors are doing, but it'll also help your team to not have to iterate through so many tools. Ultimately, though, we need to focus in and understand that garbage in, garbage out. The data quality and quantity that we get is going to affect the quality and the capability of the operable model. The data parsing is something that is absolutely critical. I apologize, I'm running out of time, so I'm going to move a little bit faster, but the integration complexities can create more of a challenge around that. And again, the skill shortage is still something that's very much a thing. The machine versus humans, these things will make determinations based off of what it sees as patterns or what are predefined logic pieces. And unfortunately, those pieces can be determined as problems and can be incorrect. So you want to have human oversight of anything that is being performed and a regular cadence of review to ensure that you are actually tracking what the models are performing and make sure that the data is correct. There's also ethical, legal, and regulatory concerns. Where's the data where's the data residing? Where's the data being processed? How is it being passed from point A to point B? Because if you're working in a regulated environment, such as government or somewhere in the EU, you have to make sure that you are tracking those pieces. Additionally, we need to focus in on the strategy. Determine what makes us successful. What are the maturity goals that we are attempting to measure against, and focus in on that. Because ultimately, everything is going to be built on the data foundations, making sure that our data feeds are accurate, that the data parsing is effective, and that we're getting what is useful. Because there's a lot that we're going to get that is absolute junk. We also need to choose platforms with an eye toward growth. Understand that your organization is not going to stay as it is. Things are going to change, and you want to make sure that you are planning for that movement in the right direction. And one thing that I'm sure this is going to make people not really happy about, but don't focus on replacing people with AI. Focus on training your people to use AI so that you can become more effective. I've seen a lot of layoffs, a lot of movement in that direction, that we need to move in that way. But we're seeing good people that are needed in the field getting dropped because of the promise of what AI could be, not what it currently is. We need to focus on upskilling and investing in our teams to collaborate on not only threat intelligence, but artificial intelligence as well. Because the continuous feedback loops that we talked about, analyst input matters. Analyst input to the AI models will determine the level of success, and it's going to build up that capability. And also, we've got to figure out a way to shift from the traditional metrics of alerts handled to the risks mitigated. This is what gets us the investment from executives, but it's also what gets them an understanding of what it is that we do and why it matters. So wrapping all of this up, I apologize. I rushed it a little bit. I know I'm running a little short on time, but ultimately AI is transforming the way that we're doing business, for better or for worse. It's a great tool, but like any tool, it can be used for good things or it can be used for evil. It is not the tool that determines the capability, it is the leveraging of that tool. So, much as the meme goes, like your 75-year-old grandmother is saving this from the apocalypse by telling the Amazon Echoes, thank you and please, every time that she asks them something. We need to focus on how we're using these tools and make sure that we're using them to leverage against effective problems, but we're also being wise in how we're doing that and not giving them too much power without oversight. Threat intelligence can drive defense operations by prioritizing solutions to problems that are actually happening for those organizations. This is something that is absolutely critical and we need to focus on. And we need to drive home that problems, if we're putting in a solution, it needs to be to address a problem. We're not just iterating on something for the sake of change. AI can enhance visibility and responsiveness when used wisely and effectively, but it has to be managed. AI integration to establish workflows can reduce analyst fatigue and alert fatigue for ops teams, but only if properly used. Otherwise, it can actually make it worse. So focus in on the solutions and drive toward them. Security teams cannot operate effectively when they are choked and rigid. We need to stay flexible. Understand that the world around us is changing in a continuous fashion. We need to be ready for that. And ultimately, I cannot stress this enough. AI is an amazing tool, and it is so cool to see this in use in my lifetime, but it's still limited, and it's got to be overseen by human expertise. Otherwise, every single time, we are going to have it cause more problems, more disruption, and cause more workload on analyst teams. So ultimately, we have got the capabilities, we've got the tools. Now we need to go and use them. Feel free to reach out to me. I'm happy to talk to anybody at any time. I'm a little hard to get a hold of sometimes, but if you've got questions, now is the time. I cannot tell you how much I appreciate your time and your energy in working with me on this. Thank you for attending my talk. So in terms of how artificial intelligence improves security operations, it's largely dependent upon how it's used. So, and that actually does tie into your second part of the question. In my experience, artificial intelligence can do one of two things. The right tool applied in the right way with the right people working on it, which basically means a tool that has the effective capabilities you need applied by people with a mind toward growth and developing of themselves, as well as understanding what the problems are they're trying to solve, can dramatically reduce overall workloads. And it can, I've used it myself to reduce noise, to improve visibility, as well as improve the quality of data that we're getting. So in a previous position, one of the things that we did was we built an artificial intelligence language model that would feed our notes from researching the event in Splunk. It would take those notes along with all of the correlated information inside of the alert, and it would automatically write a ticket. A lot of our team was English as a second language, and it would create a standard template and it would update that. So it took us from about 45 minutes to escalate an incident to it would take less than 3 seconds to dump that into ServiceNow, and it would send notifications over Microsoft Teams, Slack, as well as emails to the customer to ensure that they knew what was going on. And it was absolutely fantastic. They were able to actually query it, and it was great. So it can absolutely help teams make better decisions by allowing a faster correlation of historical information as well as bringing all of the data points that are relevant together. AI integrations with current SIEM products, a lot of them have it pre-built in because they're moving away from a traditional SIEM model and SOAR model and into a point of XDR. There are AI-specific products on the market that are absolutely spectacular. I've worked extensively with WireSpeed, cannot speak highly enough of it. There's still some challenges because it's still a new platform, but it provides an incredible level of detail. The alert cross-references IP addresses, user accounts, everything is right there in front of you, and it shows you trends on what that piece is doing. The way that you can integrate a new AI into an existing SIEM, if you don't have that integrated, one of the things that we did before I came to my current position, I was doing global security operations management, and we had Sentinel. And what we did is we built a logic app that had a tie-in to the Sentinel resource group, and it allowed it to read and process information and add additional context to that. It also gave it some degree of response activities and response capabilities. A lot of it's built off of APIs, so there is a requirement of having some degree of understanding of development processes. But if you know me personally, I can't code my way out of a wet paper bag. So using things like AI in the terms of Claude helps me to build a lot of these tools because I can't write it, but I can take and modify what I see as needed. Additionally, taking a look at some of the integrations that are on places like GitHub will allow you to find that. Also, just in general, Twitter and the information security community historically has always been very open and very willing to help others build out their capabilities and their understanding. So absolutely reach out. If you're not a part of an existing community, become a part of it, because you're going to find incredible resources that you didn't even know existed. So this one is a little bit more of a comprehensive piece because at this point you're developing an entire use case and workflow around it. So automating the log generation, the logs are going to naturally feed into your SIEM platform as part of the Intra ID typically, or as part of the Graph API integration. It's also dependent upon the level of privileges and the license that you have with Office 365, because Microsoft gatekeeps some of the better logs for higher tier license. So take a look at what you're getting in via the Graph API into your SIEM and see where that is. Based off of that, you can create lookup tables around IP addresses, domains, user accounts, information like that to cross-reference and see where pieces are. You also want to look at historical information. So things like device IDs if a user is logging in from multiple IP addresses within a short span of time, but it's the same device ID, typically you're going to see that happening with people who are on a mobile device, and it's either shifting from one cellular tower to another, or if they're using VPNs. What you're looking for is not just that one single point of reference, you're looking at a preponderance of evidence. But the key piece that you said was generating red flags and alerts when it's not within an acceptable limit. You have to make sure that you understand and have defined what is the acceptable limit and have that enforced. So it's easy to do in practice. It's much harder to understand the totality of it because it's not just a one-piece simple deployment. Informed decisions are, again, typically around building that baseline and understanding the environment and then fleshing it out from there. Understand that continuing to develop yourself is going to be absolutely critical in any field of study. Growing and developing your skills, getting those certifications, the paper itself may not get you the job, but the skills that you acquire are going to sharpen you and give you access to a toolbox that gives you a greater degree of capability. If you've ever got questions, or if I can help, if you'd have questions that you didn't get answered here, feel free to reach out to me privately. I can be reached on X, Twitter. My handle is _Rainman at Rainman_A. My email address is brian.austin628 and you can get me at brian@appalachiansec.com.